Hi, I'm Simon and I will present Group 10's final project for mobile computing. We worked on a student feedback system with the goal of giving students the opportunity to anonymously ask questions in class and rate the speed and understandability of the current lecture. Before we start the actual demo, I want to take a minute to talk about the structure of the project. The system consists of two parts, the front end, which is the Android app or a Chrome browser, and the back end, which is the web server that was realized in Python. The app itself is pretty simple, since it's only a web view with a few properties for utilizing the phone's back buttons, SSL communication, and opening links. Due to the nature of the project, students need to be able to receive updates for new votes, questions, or polls. This could have been realized with Google push notifications or a permanent and most of all manually implemented network connection. Both of these approaches came with their own set of problems. However, we decided to use HTML5 server-side events, or in short SSE. This allows us to update the website from the server. Another benefit is that we got the lecturer view, which is supposed to be a website, for free by using a full HTML implementation of the app. We will later see how the necessary GPS localization is implemented in the web view. Each user request contains the current location of the user, which is verified by the server to ensure that each student is actually enrolled. With each connection, we also connect to the class's SSH stream, which gives us the ability to update all online clients with new information when they are available. Again, each of these requests are first validated to ensure that the user is actually present in class. More on this later. The remaining video is structured according to the tasks. As can be seen, we're pretty much done with the project, except for minor design changes. As usual, the app can be started from the app menu of the phone, which initially takes us to the login screen, which has a loading animation until the position of the user could be found. While logging in with the student's student ID, as well as the password, which is at the moment the equivalent to the student ID, we are taken to the dashboard of that particular user, which shows the name as well as all the classes this particular user is enrolled in. Down here, we have the button that shows which class can currently be rated. This is filtered based on the position of the user, the day of the week, as well as the time of the day. So for the purpose of this class, we took all the graduate computer science classes from spring 2018, so all the 500 level classes would technically work with this app. And for the purpose of localization, we took all the buildings these classes take place in and gathered the GPS positions of all these buildings. So when clicking on this particular class, which at the moment just happens to take place in my office, we are taken to the dashboard of that class, which first verifies the position of the user again, and then provides the three categories, which are student satisfaction, questions, and polls. And these individual sections are discussed a little bit more in detail by my teammates. The diagrams on the side show the flowchart of the connections. This was already briefly discussed in the general overview, but is shown here in a little more detail. Essentially, after login, the user is validated and connected to the appropriate class stream. So from a code perspective, we are using a Flask server in Python. So the first step of that one is to create all the appropriate endpoints for the websites and the actual class streams, where each of the stream numbers corresponds to a class. So these endpoints are in general used to create the websites. So this is the simplest one, which just creates the index, it renders the login template, and creates the appropriate HTML response. So the login template is just a pretty simple HTML website. The interesting part about that one is actually the location function. So we're doing all of this based on the JavaScript's navigator geolocation function, which as soon as the position is found also disables the loading mask. On a side note, for the loading mask, this loading mask is taken from CodePen and is separated into the loader.css file to separate the code that we got from somewhere else, from our own code. So back to the server, endpoints can also be a little bit more complicated. For example, the endpoint for login first takes all the data from the username, the password, and the position of the user, and checks that with the database if there's exactly one user that has a match with the username and password. So in case this user is valid, we're creating the appropriate session to get the to store all the information of that user, and then we get the user's classes and the active classes. So for that, if we go back to the database class, we see that getting the classes is only getting the classes the user is actually enrolled in, whereas the active classes function is based on the class function, but in this case validates if the user is in class. So the validation if the user is in class is actually the core of the whole evaluation, because it takes the longitude and latitude coordinates from the user, and based on a formula found on this website, we're calculating the GPS distance. If this is smaller than 500 meters, we say that this user is actually in class. The next two validations are just based on making sure that the current day of the week is correct and corresponding with the class, as well as how much time has passed from the time the class should have started. If this is between 0 and 75 minutes, we're also setting the time to OK. If all of these three values are in good standing, we're returning true, and with that validating that the user is actually in the class. Back to the server method, the next thing that is actually interesting and was part of my tasks are all these different streams for the classes. Essentially all of them are mapping to the event while giving in their ID. So this event function is interesting because it actually never returns. So this is a so-called producer function, and every request to the server is handled in a new thread. So with each request that is sent to the server, or each user that logs in, a new thread is connected to this producer function, which takes all the satisfaction scores, for example, and sends them over the SSE connection to the clients. And as soon as something new happened in the satisfaction, because perhaps another user rated something, the clients are updated, all of them on a 2-second timer schedule.
Hi, my name is Bijan Fakri, and I'll be going over the user satisfaction functionality of our project. So a lot of it is done here in feedback satisfaction function in server.py, and what it does here is that it checks that the user is logged in. If the user is not logged in, it'll return the user to the home screen so that they can log in. Then it gets the class based on the usernames, and that's based on what classes the user is registered for, and then it requests the Latin longs, the user location. It then sends this information along with the time to make sure that the user is temporally and spatially in the correct class that he or she is attempting to log into. Then what it does is from the web page it gets the user satisfaction, so that's a value from 1 to 5 based on how satisfied the user is with the answers the professor is giving, and this value is sent to the server for aggregation, but it is only sent if the user has within the last 60 seconds not performed another action. This prevents users from spamming the graph and having a disproportionate amount of influence on the satisfaction graph. Then once we have that information, we render the screen with the updated render the page with the updated information. Here in feedback satisfaction.html we define the page, and here we define and show the buttons as well as create the links to those buttons. And as you can see, if we press one of these buttons, the information is sent to the server and our satisfaction is recorded here. If I press the button again, you will see that no update will occur. If we press any button, that's because these activities are occurring within 60 seconds of each other. That means that the user is essentially trying to spam the system, and we don't want that. Back to the code, we use a D3 plotting library in order to plot this. And basically what happens is in this listen to stream function, we get the satisfaction, we aggregate all the satisfactions and then average over time. And then we draw a new line and remove the old line. Thank you very much. My name is Bijan Fakri.
Hi, this is Mao-Lin. Now I'm going to introduce student question part in our project. Once user enter this question page, the question list in the basic class will be pulled out from our question database and ordered by post timestamp. And we also filter the question that user already voted to avoid duplicate voting. And then we pass above information to render final web page. Hence, as we can see, the user can vote for the question in class and insert the new question in this class. And user can also go back the page to see the question he just posed. And in lecture views, the lecturer can enter the class ID to see all the questions in the class without voting. Thank you.
Hi, my name is Shirav Dave and I would be talking about the polling system for our project. So for the polling system, we have the function called as feedback poll, which is going to read the user ID, and depending on the user ID, it would display the page. Say if it's a user ID is A, that means it's a professor, and the professor will have the facility to ask question and get the results, and if it's a student, then student will get their facility to answer to that question. So let us go there. So the user ID, so we'll first log in as the professor. We'll go to this tab and we'll ask a question, say hello, and then we'll log in as a student and we'll go back to the poll and we'll give the result as yes, answer as yes, sorry, and then this is how the professor will get the result. Thank you.